Hi everybody, today we are going to study about rational functions. Okay, in that if we define a function f from R to R, which is a set of a real number to a real number, and defined as a function f of x is equal to g of x upon h of x, where g of x and h of x are polynomial function, which we have studied in our last lecture. And here we have to define that h of x should be not equal to 0. If it is equal to 0, the value will goes toward infinity, so it will not equal to 0. As rational numbers definition also says that it is a number p upon q such that q not equal to 0. That is, here if we define a rational number, it is p in the form of p upon q, where q not equal to 0 and p and q are integers. Okay, in that manner that types also rational function is defined. Okay, now if we take a function f of x is equal to x square minus 1 upon x plus 3. So here we have to find the values of x such that, or we have to put the values of x such that it should not be equal to 0. This denominator, if denominator is 0, so its value will be not defined. So we have to find the value of x plus 3 not equal to 0, that is its denominator not equal to 0. Now to find not equal to 0, we have to take x plus 3 not equal to 0. So for domain, that is for domain purpose, to find domain, we have to take x plus 3 not equal to 0, which means x not equal to minus 3. Therefore domain of f will be R minus singleton minus 3. Okay, so it will be our domain, and range of f, it is all belongs to real number. Okay, in other example, if you consider f of x is equal to 3x minus 2 upon x square minus 1. In this also we have to find the values of x such that x square minus 1 not equal to 0. So that is, we have to find the domain so that it will be not equal to 0. So to find domain, we have to find x square minus 1 not equal to 0. That is for values of x square not equal to 1, that is x not equal to plus minus 1. So our domain of f will be belongs to R minus 1 comma minus 1. Okay, these 2 points does not included in a domain set. And range of f, that is, if we put any value, real value, that is of x in this function, the value which we get will be the value of y or f of x, which is our range. So here range will be R. Okay, now if we consider a function f of x is equal to 1 upon x, where x not equal to 0. So if we draw the graph related to this function, so we draw first a table with values of x and f of x. Here if we consider x, here if we consider f of x. For x is equal to minus 2, here it will be minus 1/2. F of x will be minus 1/2. For x is equal to minus 1, it will be minus 1. For x is equal to 1, it will be 1 upon 2. Sorry, 1. For x is equal to 2, it will be again 1/2. For x is equal to 3, it will be 1 upon 3, and so on. Okay, So graph related to this function will be, if you draw a graph related to y is equal to 1 upon x or f of x is equal to 1 upon x, the graph will be look like, it is x-axis, here it is y-axis. So here function, it is for x not equal to 0, so it will not go through or intersect origin. So here values for 1, it is 1. Okay, if you consider this point 1, it is 1. For value positive 2, it is 1/2, which is 0.5. okay, so for 2 it is 0.5, it will be less. For 3 it is 0.3, it will be nearer to x-axis. For 4 it will be 0.25. okay, so it will become, if we increase the value of x, it will be go nearer to x-axis, but it will never be 0. If we consider x is equal to if we consider x is equal to 0.1, so its value will be 1 upon 0.1, 1 upon 0.1, which means 1 upon 0.1, which means 0.1 is nothing but 1 upon 10, or 1 upon 0.1 is, its value is 10, or we can write it as 1 upon 10, because 0.1 is 1 upon 10, which is equal to 10. okay, so for nearest value of 0.1 it is 10, if you consider it as 0. Next, for 0.5, if we consider x is equal to 0.5, which is 1 upon 0.5, which is equal to, which can be written as 1 upon 0.5 upon 10, which is equal to 10 upon 5, which is equal to 2. So for 0.5 it is 2. okay, so it will be come nearer to y-axis. If we decrease the values, it will goes increasing and increasing, but it will be nearer to y-axis, it will not intersect. okay, so if we plot the graph from this values points, so it will be look like this. okay, so this is our positive part of 1 upon x. If you draw for negative part, it will be a symmetric part. That means for negative -1 it is -1, for negative -2 it is -1/2, which is nearer to. Next it is for 3 it is 0.3, 1 upon 3, so it will be minus nearer. So for it is 0.5 it will be 2, for 0.1 it is 10. So if you draw the graph related to this point, it will be look like this. okay, so it is a symmetric graph. For this will be for positive part of 1 upon x, and this part will be for negative part of 1 upon x for values x less than 0. In this part it is x less than 0, in this part x is greater than 0. okay, this will be graph of a rational function 1 upon x. okay, so this is all about rational function. Now in this example, for f of x is equal to 1 upon x, domain will be, domain of f will be belongs to R, and range of f, here it is R minus 0. okay, because if it is 0, x is equal to 0, it will be not in it function. okay, so it will be infinity, so range of f will be belongs to R only. okay, this is all we say about a rational function.